Using the binomial theorem for this guy isn't that amazing because the power's not that big. Okay, but we are just practicing, right? Right. Okay, so we're going to find the third term and we're going to find the fourth term. Okay, two ways, or two different problems. Okay, so to find the third term, we would know that there's three parts to it because it just is. And the first term in the binomial is 3a, so you're going to put 3a right there. And the second term is b. All right. Now, I know we have a power of 4, and I know that we're looking for the third term, so this would be a 2. Is everybody cool? Yep. Okay. I know this 2 because this usually always, actually not usually, it always matches the second power. And then this one is also 2, which is like, you might be thinking that we're copying it, but we're not. This is actually 4 minus 2. That's why we get that. And we get the 4 minus 2 right there. Okay? Okay. All right. So, now you know what 4 choose 2 is because we just did that a couple times, but I'm going to do it again. That's 4 factorial over 4 minus 2 factorial and then 2 factorial. Okay? So it's 4 factorial over 4 minus 2 factorial and then 2 factorial. Okay, so we simplify this. This is going to be 4 times 3 times 2 times 1. On the bottom we have 2 factorial and 2 factorial, which are just 2's. So it's 2 times 2. I could simplify it like this. 2 times 2 is 4, so I can cancel that guy out. You could do it a different way. It doesn't matter. You still get a 6. And so I get a 6 for the first term, or first part of the term. And then what is 3a to the second power? 9a squared. And then I put b squared. So this simplifies to 54a squared b squared. So if you actually multiplied this all the way out, the third term should be that.
I was right.
Okay. Now, next one. Let's do the fourth term. Okay, so for the fourth term, again, you have 3 parts to the term. You have the 2a, or the 3a part. And you have the b. We have a power of 4. What are we choosing here? 3. So we know that this is a 3 because we want the fourth term. It's always the number term minus 1, okay? And so what's the power for this guy? Because naturally, that would be 3. And then what's the power for this guy? It is 4 minus 3, which is this, which you guys know is Uno. Okay. Now, we got to go 4 choose 3. And so that'd be 4 factorial over 4 minus 3 factorial, and then 3 factorial. 4 minus 3 is just a 1. 1 factorial doesn't do anything, so he gets ignored. On the top, I go 4 times 3 factorial over 3 factorial. What is 3 factorial divided by 3 factorial? 1. Uno. So we're left with 4. So this is a 4. So I have 4 times, what is 3a raised to the 1 power? 3a times b raised to the third is just b to the third. So what's my final answer? That is the fourth term for this binomial expansion. All right, one of my awesome students had a great question, and that question was, how the heck does this relate to the Pascal's triangle? This guy and this guy. Those ones relate to Pascal's triangle. I'm about to show you really quick. Here, check this out. It goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, right? This is when n equals 0, n equals 1. Okay, the n's, those are powers. This is when n equals 2. When n equals 3, that's this dude. And when n equals 4, that's this dude. So I want to take this guy right here and pick him apart for a second. Okay? This is true for every single row in Pascal's triangle. Are you ready? Okay. When n equals 4, if you wanted to find the row in Pascal's triangle when n equals 4, that's which row? It's the 1, 2, 3, 4, 5th row. Okay? So if you wanted the 5th row for Pascal's triangle, this is how you'd figure it out. 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, oops, I did the fraction thing, and then 4 choose 4. 1, 2, 3, 4, 5. There's 5 numbers in the 5th row, right? 1, 2, 3, 4, 5. So this number, what do you think it equals? And what does this number equal? What does this number equal? Yeah, we already did that one. What's this number equal? What does this number equal?
That one.
Okay, so the combinations can be like used to find each term in the Pascal's triangle. So if you guys are using combinations, how would you find the let's go 15th row? That's that. Yeah, we're not gonna do all of them. The 15th row in Pascal's triangle.
That would be negative 11.
Okay, that would be when n equals what? 16, right? So the first number in the 15th row is a 1. It'd be 16, choose 0. What's the next one?
16, choose 0.
Wait, did I do that right? Is it supposed to be when n equals 16? No, it's supposed to be when n equals 15 or 14.
Yeah.
It's one less. You jerk faces. You're trying to make me make mistakes. I didn't do it. This is how you would find each term. When do I stop doing this? Guys, when do I stop doing this?
Until you get to 14.
14, choose 14. How many terms, how many numbers would be in the 15th row of Pascal's triangle?
15.
It's 15, right? Fifth row, 5 numbers. 15th row, it'd be 15 numbers.